In this video, we are going to look at lesson 7.07, margin of error. So we have some vocabulary here. The first one is the point estimate. That is the center of this interval estimate. That's going to be represented as p hat or x bar used to estimate population parameters. So in this case, we're taking sample data and we're estimating the population parameter. So we're saying the population parameter is going to be somewhere within the interval estimate. Okay? Now the margin of error is the difference between the point estimate and the parameter. All right, so here are some ways you can see the interval estimate written. So you can have the point estimate plus or minus the margin of error, so such as 10% plus or minus 3%. Now you could write it as limits, so it could be between 7 and 13. Or you could write it as an interval notation using the lower limit and upper limit where you've got 7% to 13%. So here's an example. So a survey asked a sample of vacationers how far they drove to get to their destination. What is X bar, which is the average of the interval estimate? So if the interval estimate is 155 miles to 176 miles. So that means we've got 155 miles to 176 miles. We are being asked to find the center. So to do that, you just add these up and divide by 2. You want to find the midpoint. So 155 plus 176 and divide it by 2. And you should get 165.5. So the X bar is equal to that 165.5. All right, so in this example, you're going to determine the interval estimate, where you have the point estimate is 12, and the margin of error is 3. So you've got the margin of error on both sides, so that means you're going to subtract 3, so your lower interval is at 9, your lower limit, and your higher limit is at 15. So that means your interval estimate is between 9 and 15. All right, so let's look at calculating the margin of error. So you have this formula right here, where your margin of error is equal to the upper limit minus the lower limit divided by 2. Okay? Then you can take the half range, which means you just take the lower minus the upper, or the upper minus the lower, and divide it by 2, and that gives you your margin of error. So the margin of error in this case is approximately 0.14. And you would get that from the upper range, upper limit, minus the lower limit divided by 2. Now calculating the margin of error, you can also use standard deviation. Okay? And if we use the 2 standard deviations from the mean, then you'd use 95% of the data. So to do that, we know that most of the majority of the data is distributed within 3 standard deviations. So the data is comprised of roughly about 6 standard deviations. You've got some outside of that. So you can divide the range by 6 to arrive at the estimate of the standard deviations. Okay? So this is one way how you can calculate the margin of error using the standard deviations. You can divide your range up by 6, and then you can divide it up within 2 standard deviations, and then you can find your margin of error that way as well. Alright, so let's say we wanted to use the standard deviation. So we would take our range, divide it up by 6, okay? So that is our margin of error, and if we wanted to find it within 2 standard deviations, so our margin of error would be 0.092 within 2 standard deviations. Okay? So that is one method how you can find the margin of error if you wanted to include 95% of the data. And sometimes we do this if we have outliers. If we have outliers or points that are way far out there, this method is typically better. If if you don't have any outliers, then you could use the half range method. All right, so in this case, we're going to determine the margin of error in the point estimate. So we know the interval range goes from 7 to 15. And we need to find the x bar. So you can take your 7 plus 15, divide it by 2. So we get 11 in the middle. So the point estimate is 11, and the margin of error, that's where you take your 11 minus the 7. So we get the 4 for our margin of error. So you got 4 on both sides. So your margin of error is 4 in this case. All right, so why do we use margin of error and why do we use the intervals? It's because we're trying to estimate for the population proportion or the population parameter, whatever it may be, either proportion or average or whatever it is. And in this example, it's a proportion. So if we're trying to estimate for the proportion, we can set it up as a range. We could say the population must be between this number and this number. So that's what we're doing. We're estimating for the population. So let's practice. So the results of a survey indicate that the proportion of voters who support a new bill is likely in the interval of 0.18 to 0.24. Okay, so we've got the interval from 0.18 to 0.24. So what is the margin of error in the point estimate as a decimal? So let's add them up. So 0.18 plus 0.24 and divide it by 2. So we have 0.21 as our point estimate. So 0.21 is your point estimate, and the margin of error is going to be 0.03. Okay, so your margin of error is basically plus or minus 0.03. All right, so if 200 voters were randomly selected, what is the best estimate for the number who support the bill? So if you have 200 voters, you would take that 200, multiply it by your point estimate, which is 0.21, 21%, and you get about 42. So you'd have about 42 people who would support the bill. You could also write it as an interval. Okay, you could multiply it by 0.18. So we've got 36. Remember, the middle is at 42. If you take that 200 and multiply it by 0.24, get 48. So what is the best estimate? So we could say between 36 and 48 people is the best estimate for people who support the bill. So of those 200 voters, around between 36 to 48 people. And our point estimate gives us 42. All right, so let's look at this one. Write the interval in the form of lower limit to upper limit in interval form. So we've got 26 plus or minus 2.5. So you can take your 26 minus your 2.5. So we have 23.5. And then take your 26 and add your 2.5, and we get 28.5. So your interval estimate is between 23.5 and 28.5. So in this case, you're going to find the margin of error. So if we know it's between 71% and 74%, we need to find the margin of error. So find your point estimate. So 71 plus 74, divide that by 2. You get 72.5. Then find your margin of error. So we know there's 1.5. 1.5. So it's plus or minus 1.5. So your margin of error is 1.5 in this case. All right, so find the interval estimate. So we know that it's between 4.193 and 4.355. All right, so find the middle. 4.193 plus 4.355. Divide that by 2. So my point estimate is going to be 4.274, and then we need to find the margin of error. And I have 0.081. So that means it's going to be 4.274 plus or minus 0.081. So 4.274 plus or minus, there we go. So that is how you would write the interval estimate and the point estimate plus or minus margin of error. All right, so in this case, we're going to write the interval estimate for the proportion of all the computers that have a virus in this form. So we have the interval estimate form. So in a random sample of 410 computers in a building, 4 of the 35 chosen computers had a virus. So the sampling method had a margin of error. Okay, so we need to find 4 divided by 35. So that means my p-hat is 4 divided by 35, which is 0.114. So that means we have 0.114 plus or minus the 0.035. So take that plus 0.035. So that means I have in my interval with the 0.114 in the middle. So my upper limit is going to be 0.149. And my lower limit is going to be 0.079. So we go from 0.079 to 0.149. So that's how you would write it in upper limit, lower limit form. Or lower limit, upper limit form. I'll say that backwards. All right, so let me know if you have any questions over this lesson.